So we're going to review factoring, which comes out a lot on the final exam. The first type of factoring we learned was pulling out the GCF. So what's in common in the two terms of this binomial? There's a multiple of 3, and there's also an x. So you could pull out a 3x. That's what you call the GCF. And factoring is like doing distributive property backwards, where you say 3x times what gets you back to 6x squared. That is 2x. And then 3x times what gets you back to a minus 9x. That is a minus 3. And that's it. That's the first type of factoring we learned. That's the first type of factoring you're always supposed to attempt. Another type of factoring is where you have a quadratic trinomial, ax squared plus bx plus c, where the a value is 1. When the a value is 1, that means when you don't see a number out here, it's really easy to factor because you could set this up, parenthesis, 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 xx. If you had a number out here, you would not be able to set this up. The reason why we're able to set this up is because if we started multiplying, x times x will get us that x squared. So if you had a 6 right here, you wouldn't be able to say x times x. It might be 2x times 3x. It might be 3x times 2x. It might be 6x and 1x. There's a lot of different possibilities. So whenever you have an a value of 1, you could set it up like this. And then you think what times what is the c value, negative 24, that if you combine together is the b value, the minus 2. So I always say make a list of the multiples of the c value of negative 24. So I always start with the number 1 or negative 1. Negative 1 times what is negative 24? Negative 1 times 24. Negative 2 times what? Negative 2 times 12. Okay. How about negative 3? Negative 3 times something give you negative 24? 8. Okay. What the heck's going on here? 8. Negative 4 times something give you 24? 6, right? And if you don't know, use a calculator, right? But anyways, you make that list, and then after you make the list, you got to think, which of these numbers, when I combine them, gives me the middle value b? What is 24 plus negative 1? That's 23. That's not 23, so this pair of numbers is not it. Bam. How about 12 take away 2? That's 10. This b value is not 10, so that's not it either, okay? How about this guy? 8 take away 3, that's 5. That's not a 5. That's not it either. How about this guy? 6 take away 4, that's 2. And that is a 2, but it's a negative 2, not a positive 2. That means I have the right number 2, but the wrong sign. That means these numbers are the right numbers, just the wrong signs. So you're going to pick these numbers and change the sign to a positive 4 and a negative 6. That goes plus 4 right there, minus 6 right there, and voila, we have factored. What do you guys think? It's not that bad, right? When you have no number in front, you just think what times what is this number? That if you combine together is this number, and you plug them in right there into your factored form answer format. Now, it does get more challenging. What if you do have a number out here? Then you cannot do this. You cannot do that. Why not? Because x times x is not 4x squared, okay? So we cannot do that. This is one of the more challenging questions of factoring because it does require a 4-step process, and we did have a longer method, but this is like the shortest possible method, which is still kind of long. But it says right here, the steps. By the way, I just posted this in Google Classroom, this exact PDF copy, so you could have it available to you, so you could use as notes. Whenever you have a number out here, follow these steps when they ask you to factor, okay? And this is only because the a value is not 1, the a value is 4. So step 1 is to multiply a times c. So if I go a times c, that'll give me a negative 12. That's my answer for step 1. A times c equals a number. That number is negative 12. Step 2, make a list of the multiples of that number, a list of the multiples of negative 12, and find the pair that combines together to give you b. So let's first make a list of the multiples of negative 12. So here's my step 2, making a list. Negative 1 times 12, negative 2 times 6, negative 3 times 4, and that's it, okay? Now, which of those pair of numbers, when I combine them, gives me the b value, which is 4 in this case? Remember, it's ax squared plus bx plus c. Which of these numbers, when I combine them, gives me the middle value 4? Anybody? The negative 2 and 6. That's right, the negative 2 and 6. Thank you for participating. All right, negative 2 and 6. So what do we do with that pair of numbers, negative 2 and 6? you plug in those numbers into the AX binomial times binomial format, okay? So here's my step 3, parenthesis, 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 AX, which in this case is 4X, right? The A value is 4, so put a 4 right there with an X. And AX over here as well, 4X. And then you take the pair of numbers from step 2 and just plug them right into those blank spots. The -2 right there and the +6 over there. Now, this is definitely not the final answer. Why not? Because if I go 4x times 4x, it will not give me 4x squared. It will give me 16x squared. So we still need to do this fourth and final step, which is called, or what does it say? It says magically divide each binomial by whatever you can, okay? So we could divide the first binomial by 2. The 4 and the 2, they're both divisible by 2. So here's my fourth step, coming up with the final answer by dividing by whatever you can. The first binomial, you could divide by 2. 4x divided by 2 is 2x. -2 divided by 2 is a -1. The second binomial, we could also divide by 2. 4 and 6, they're both divisible by 2. 4x divided by 2 is 2x. 6 divided by 2 is 3. And voila, we have factored. If you were to distribute 2x times 2x, it would give you the 4x squared. 2x times 3, it'll give you 6x. -1 times 2x is a -2x. The -2x plus that 6x will give you that middle term, +4x. And then -1 times +3 will give you that -3 at the very end. Anyways, that's how to factor. 4-step process. Takes a long time. Use the notes to be able to do that. Now, you may be thinking, why the heck do I want to do distributive property backwards? Why, if this is the answer, why do I want the multiplication problem, right? The reason is, if you have an equation and it's set equal to 0, and you have something times something equals 0, you could split them and set them each equal to 0. Let me give you an example of that. So I just randomly made this up. I have something times something equals 0. When you have something times something equals 0, the first something could be 0 or the second something could be 0. That's called zero product property. That means you could split them and solve and just write down, well, 2x plus 3, that could equal 0, and x minus 7, that could equal 0. And you solve both of them just the way you normally would. Subtract 3 on both sides. You'll have a 2x equals -3 left over. Divide by 2, divide by 2. You're going to get x equals -3/2. That is one answer. The other answer is even easier, +7 plus 7, x equals 7. So those are your two answers for this equation where you have something times something equals 0. So the idea is, if you have a quadratic trinomial and you wanted to factor it, split it, and solve it, you'll be able to do that. So I guess we need to understand that sometimes they're going to ask us to factor a quadratic trinomial where the a value is not 1. And sometimes they're going to ask us to solve a quadratic equation when the a value is not 1. So let's practice factoring using the notes that we just covered, those 4 steps. Step 1 is to multiply a times c. What do I get when I multiply a times c? Help me out here. -18. Okay, so that's the answer for step 1. Step 2 is to, in case you forgot, make a list of the multiples of that answer, -18. So let's start with -1 times 18, -2 times 9, and -3 times 6. And that's it. If you go -4, it doesn't work, and -5 doesn't work, get to 6, you're already back to 6 times 3. So out of these 3 pair of numbers, when you add 18 minus 1, that gives you a 17. That's not a 17. It has to combine together to give you the middle value, -7. If you combine 9 and -2, that gives you a 7, and that is a 7, but you want it to be negative, not positive. So that is the right pair of numbers. It's just the wrong signs. So change that to a +2, change that to a -9, and you have your answer for step 2, the pair of numbers, right? Now, what do you do with that pair of numbers? That's step 3, where you go AX and AX, and you plug in that pair of numbers into your blank spots. So what is A in this case? A is 6, B is -7, C is -3. So when I say AX, I'm talking about 6x. So let's write down 6x here, 6x there, and you plug in the pair of numbers from step 2 right in there, +2 and -9, okay? Nice and simple, +2 and -9. And step 4 is where you get your answer by magically dividing each binomial by whatever you can. This first binomial, 6 and 2, you could divide both of them by what? By 2, right? So what do you end up with when you divide both by 2? Well, 6 divided by 2 is 3 with an x, and 2 divided by 2 is a 1. And this other one you can't divide by 2, but you could divide by what? By 3. So 6 divided by 3 is 2, and we're talking about 2x. And 9 divided by 3 is negative 3. And voila, we have factored. Okay, here's our answer for the factored form of the original. Okay, so if they ask you to factor, you have to go with these 4 steps. If they ask you to solve, well, first you got to make sure it equals 0. Right here it doesn't equal 0 yet, so we're going to subtract 3. We're going to rewrite it. 6x squared minus 7x minus 3 equals 0. And now you could recognize that this quadratic trinomial is that one, which means that if you factor this with these steps, you'll get to this, which means you'll be able to go something times something equals 0. You could split them and set them each equal to 0 and then get your 2 answers. So that is one option. However, not all quadratic trinomials are factorable. So you could always fall back on the quadratic formula to solve any quadratic equation, okay? So let me actually just do that, practice with the quadratic formula. So again, the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. And whenever you use a quadratic formula, you want to rewrite it with parentheses instead of the b, the a, and the c. And of course, you got to plug in your b value. The b value is negative 7. So you plug that in right there, negative 7, and right there, negative 7. The a value happens to be 6. So we're going to plug in the 6 right there and down here. And the c value happens to be negative 3. C value is negative 3, so plug that in right there. Now, when you do this, start with the discriminant, and you could do this all in the calculator, the inside of the square root. I wouldn't type in square root. I would just do parentheses, negative 7 squared minus 4, open parentheses. Do this exactly the way it is on the calculator, or you could do it the way I'm doing it right now in your head. Negative 7 to the second power, that's 49. 7 times 7 is 49, or negative 7 times negative 7 is positive 49. And then you have, then you have negative 4 times 6, that's negative 24, and negative 24 times negative 3 is a positive 72. And of course, you could use a calculator for that. So when you add 49 plus 72 inside the square root, you're going to have a 121. Okay. And on the outside, you have the positive 7 divided by 12. Okay. So luckily, this square root of 121, that's a perfect square number. You could do it on a calculator. That does equal 11. So what we really have is 7 plus or minus 11, no more square root, over 12. And that plus or minus right here actually provides 2 answers, 2 situations. The 7 plus 11 over 12, and also the 7 minus 11 over 12. So up on top, 7 plus 11 is 18, 18 over 12. 18 divided by 12 you can't do, but you could at least reduce that by 6. And if you reduce by 6, you're going to get 3 over 2. And that is your answer, 3 halves, or 1.5, or 1.5. The other one, 7 take away 11, that's negative 4 divided by 12, which you can't divide negative 4 by 12, but you could reduce by 4. You could reduce by 4, and you get negative 1 over 3. So negative 1/3 is the other answer. So we got our 2 answers to this system using the quadratic formula. But you didn't have to do that. You could have factored, split it, and solved it. So if we would have gone from here, equaling 0, to this factored form, all you have to do is put the equal 0. Then you could say, oh, something times something equals 0. The first something could be 0. The second something could be 0. So you could write 3x plus 1, that could be 0. 2x minus 3, that could be 0. And if you solve both of them, subtract 1, you're going to get 3x equals negative 1. Divide by 3, and you're going to get x equals negative 1/3. And then the other one, same deal, add 3. You're going to get 2x equals 3. Final step, divide by 2, x equals 3 halves. So either way, you get the same answers, negative 1/2 and positive 3 halves. I'm sorry, that's negative 1/3. I read it wrong. Negative 1/3 and positive 3 halves, negative 1/3, positive 3 halves. Depends up to you if you'd like to factor or if you want to use a quadratic formula. Either way, you get the same answer. But I will tell you this, sometimes I mean, for me at least, whenever I have an equation and I could identify the A, B, and C, I like to do the quadratic formula because sometimes it might not even be factorable. When you're trying to find out which pair of numbers combines together to give you a middle value, sometimes it's not factorable. So you're going to have to go with the quadratic formula anyway. So again, if you have something that's already factored, all you have to do is split it and solve. X minus 3 equals 0. 5x plus 1 equals 0. That means that x equals 3. And x equals, if you do the math correctly, negative 1 divided by 5 would be the other answer. Okay. And of course, if you had, again, A, B, and C, you could factor it, but I would just identify A, B, and C and use a quadratic. So there's a quadratic formula. And when you use a quadratic formula, please replace everything with parentheses before plugging in your B, your A, and your C. And of course, your B value is 5. So the 5 goes right here and right there. The A value is 2. So that goes right here and down here. And the C value is negative 3. So that goes right there. You're going to always begin with the discriminant, the value inside the square root. And you could type that in exactly the way it looks into the calculator, and it'll give you your discriminant value. Or you could do it by hand the way I'm about to. 5 squared is 25. I'm just going to write a 25 up here somewhere. Then I go minus 4 times 2. Minus 4 times 2 is a negative 8. A negative 8 times a negative 3 is a positive 24. So inside my square root, I have 25 plus 24, which is 49. So my new problem becomes negative 5 plus or minus the square root of, we said 25 plus 24 was 49, and that is still divisible by 2 times 2, which is 4. Now that plus or minus provides two different answers. You're going to have the negative 5 plus the square root of 49 is 7 divided by 4. And you're going to have negative 5 minus 7 divided by 4. Maybe I should have shown my work and shown that I replaced the square root of 49 with 7. Okay, and then you could have split it to the plus 7 and the minus 7. Anyway, so when I do the final step here, negative 5 plus 7, that's 2, and it's still over 4. And 2/4 reduces down to 1/2, so there's an answer. The other one, negative 5 take away 7, that's negative 12, and negative 12 is divisible by 4, so you get negative 3 as the other answer. And that's about it, guys. We could have factored this, doing those 4 steps, A times C, then thinking of the multiples of that answer that combine together to give you B, and then you rewrite it in your AX parenthesis with the parenthesis AX, right? And then you magically divide. But anyway, I like the quadratic formula, especially if you're working on the final exam and you're seeing that the answers have like square roots involved, go with the quadratic formula. If you see answers, like all 4 answers, A, B, C, and D, are all nice answers, like 1/2 and negative 3, or like 4 and 5, or like 7 and 2, then you could try to factor, split, and solve because you don't have any irrational values.